Hey guys, I'm the math professor, Kyle Martin. This is a channel where we do your math homework fast and accurately. Today we're doing a two-column proof, right? 1, 2, where we prove these two triangles to be congruent with this given information up here. All right, so I'm going to start by writing in my given and my proof statements down below. If you don't know how to do that, I explain it pretty good in a video up here. You can check that out. Otherwise, let me do this real quick for you. All right, so I got all the information filled out over here, and now I need to probably mark up our triangle to see kind of what that did for us. All right, so first off, it told me that GC is congruent to MJ. All right, so GC and MJ, that's the top and the bottom lines there. They're congruent, so they can just get one tick mark each to show those congruents. Okay, our second line told us that those same lines, the top and bottom, GC and MJ, are also parallel. Remember, we can show parallel by putting arrows on those. So I'll put one arrow kind of on each one to show those are parallel to each other. All right, so then what does that really do for me? Well, when things are parallel and we're trying to prove triangles to be congruent, we have to remember when we had two lines that are parallel with a transversal, a lot of times we had those kind of alternate interior angles, and that's going to really be key here when we connect G with M. We're going to have those alternate interior angles. In fact, I could prove right away that angle 2 and angle 1 are going to be congruent to each other for that very reason, alternate interior angles. All right, so once I got that marked on my picture, then I have to kind of take a look at what I have. I have a side, an angle in this triangle, all right? And angle 3, I really can't say that's alternate interior angle with 4 because that doesn't even touch my line that is parallel, all right? So what else do I have here? Well, I'm thinking that G and M is going to be congruent to each other, GM and GM, because of they're the same, right? When two sides butt up against each other and they share a side, those sides are going to be the same. All right, so we can put two tick marks kind of on it, and we'll see how that works here in just a second. All right, but then what that does for me now is I have a side, an angle, and a side, and on the top one I have a side, an angle, and a side. And so side, angle, side is going to be probably my last reason down here, side, angle, side congruence. So then I just have to tell this kind of fourth spot that G and M are congruent. Let's do that. So I think though, when I do it, if we look at G and M in this fifth one, we're trying to prove that to be true. And over here, the G comes second and the M is our first, and our first spot. We actually need to say this. We're going to say GM is congruent to MG. We're going to flip it around because they're flipped around in those two. And when you flip something around, even though it's the same two letters, that's actually the symmetric property. All right, so by the symmetric property. And then I can say my proof statement, and we said earlier that that was side, angle, side, because of side, angle, side, and up here, side, angle, side. Hey guys, if this video helped you out, check out this video where we do another triangle proof, and we'll see you guys in the next one.